Alright guys, let us begin with the very first unit from our class 9 CBSE book, that is motion. So guys, this is the very beginning of this lecture, in fact, the first video on this tutorial. So guys, let us focus on first understanding what is motion. So guys, before that, let us just see what will be the objective of today's lecture. So first we will be going through understanding motion. We will be going through the different parameters which are used to describe the motion of an object. And finally, we will see the difference between the scalars and vectors with example, guys. All right, so let's quickly begin up, guys, without wasting much time. And here we have what is motion, guys. So first you have to understand movement. In short, if I have to define motion, guys, it is nothing but movement of an object with respect to the surrounding. So guys, this phrase with respect to surrounding, that is very important because guys, generally, whenever any object or any particle or in fact any body moves, that moves with respect to its surrounding, which is called its reference frame, right? It is called reference frame. So guys, I'll tell you an example here by which you can relate that what do I mean to say when I involve here surrounding frame. Guys, here let us say that there is an object here. There is in fact a boy on the ground and there is a tree here. So guys, now when this boy starts moving, let's say after some time the boy now reaches position B. So guys, here boy has changed his position, but with respect to the tree only, the boy has changed the position. So guys, it is now very clear that involving the use of the reference frame or the surrounding is very much important. It's very much crucial to describe the motion. So guys, now if I would ask a general question, is motion just a movement? Definitely not, guys. It is movement with respect to the frame of reference, or you can say with respect to surrounding in short. All right. So guys, here let's just observe a simple scenario here. Let us say an object is initially positioned at O, right? Initially positioned, that means let's say at the start of the time, the object is at O. So when it starts to move, let us say in 4 seconds, the object moves till point C and stops there, right? So guys, if we observe this number line, we can say that in 4 seconds, the object has covered 25 kilometer. This much cannot be, this much distance cannot be covered in very short span of time. But still, let us just take an example that in 4 seconds, a particle covers 25 kilometers, right? So basically, this object has moved. On this reference frame only, the object has moved, but with respect to the surrounding here or with respect to the point, right? So here, guys, it is very clear that what is a motion. Let us move ahead to explore all the parameters used to describe the motion of a particle. So guys, parameter is very important to scale up here because these are the variables which describe the complete movement of an object, right? So guys, here you might have all heard about this distance, displacement, speed, velocity, acceleration, momentum, time, and etc. There are many parameters, guys, which we are yet to explore in our higher grades. But as of this stage, understanding the meaning of these parameters, that is more than enough, guys. All right. So let us first begin with distinguishing between this distance and displacement. Okay. So before moving ahead, guys, let us first observe what are the different types of motion, right? So guys, let us say an object moves in 2 seconds a distance of 10 meters. In next 2 seconds, object moves a distance of 20 meters. And in the next 2 seconds, the object moves a distance of 10 meters again. So guys, here we can see in this span of time, the object has moved 10 meters. That means there was some speed of the object. But if we observe the second time frame, that is the next 2 seconds, object has covered greater distance, guys. That means the object more was having more speed and in this time interval, right? So guys, based on this condition, we can say that this type of motion that the object is covering, that is a kind of non-uniform movement or non-uniform motion. So with the phrase itself, guys, it is very much clear that what do we mean by non-uniform? Means the motion which is not uniform or which is not constant. In short, it is not constant. If it is not constant, guys, I can definitely say it is variable. So motion is variable. That means definitely motion here is scaled up by the parameter speed, right? So later on, guys, after going through acceleration, after understanding its meaning, we will return back again to the types of motion and define these uniform and non-uniform motions on the basis of the types of acceleration. All right. So guys, now let us move ahead to explore the very first parameter here, distance and displacement. So guys, be focused. This is the point where actual mechanics start. The actual story behind the motion starts. So guys, first to understand distance and displacement, let me just introduce you an example. Let us say there was a boy and that boy started his journey from home and covered this path 1 to reach a point, let us say P. And the boy covered 4 meters or let's say 4 kilometers in 30 minutes or let's take 30 seconds. It will be better if we take in terms of hours. Let's say 1 hour. Again, the boy covered path 2 to reach the school and this distance was 3 kilometers, right? And this was covered in, let's say, another 1 hour. So guys, if we observe the movement of boy, first the boy went from his home to P and then went via path 2 to reach school. So guys, here if we talk about the total distance moved by the object or by the boy, that is nothing but 4 kilometers plus 3 kilometers. In short, it will be 7 kilometers, right? Distance is 7 kilometers. But guys, on the same time, if we talk about displacement here, remember guys, how do we find out displacement? Just we measure out the shortest path or the shortest distance between initial to the final position, right? So guys, here we may be confused at which path to take as the shortest. Remember always that the shortest straight line joining between the initial and final position, that is your displacement, guys, right? So the one which I have drawn with green color, that is my displacement. So guys, if I say that this was at right angle, the two paths were at right angles, we can easily say that the displacement was 5 kilometers. How did I get this 5 kilometers, guys? Just by using simple Pythagoras theorem. So from home to P to S, this angle was 90. So guys, this one which I have to find, that is my hypotenuse. And we have the other sides, 3 and 4. So what is the formula for hypotenuse? Square root of 4 square plus 3 square. And that just gives us, guys, 5 kilometers, right? So guys, one thing here is to be understood. When we are talking about distance, we are talking about the total path length covered, right? Distance is the total path length. It is total path length. You can even remember this definition, guys. You can note it down. Distance is the total path length covered. And on the other hand, displacement here, this was the shortest distance, right? This was the shortest distance. And definitely if we talk about the direction, guys, which amongst them had the directions? Definitely it is the displacement, guys. It had directions. So guys, if in short I have to compare distance and displacement, we observe that distance has only magnitude. Magnitude means just the value, like 5 kilometers, 6 kilometers. Magnitude means value. But on the other hand, displacement has magnitude as well as it has directions associated with it, right? So you can see in the previous slide, guys, where we took the boy moving from his home all to the way to the school, and this was displacement. It was always oriented from initial to the final position, right? This arrow pointing from home to the school, the straight arrow, that means its direction is confined and fixed at every point. That is the direction. So always remember guys, distance always has magnitude only, and displacement on the other hand has magnitude as well as direction. Now guys, based on this quantity having magnitude and the quantity having magnitude with direction, we will categorize physical quantities into two subparts. One is scalars and the another one is vectors. So here, scalars guys, they are just the quantity which has only the magnitude. So what could be the possible examples of scalars? Distance, right? On the other hand, we have vector quantity. And what is vector quantity, guys? Those quantity which has magnitude as well as directions associated with them, right? So guys, there is a small trick over here which is going to work almost in all kinds of quantities. So if I would ask, what is force? Is it a scalar or a vector? So guys, you did not learn all the quantities categorized under scalars and vectors. What I would suggest is just go through this scalars and vectors. Just remember that distance is scalar and displacement is vector. Now I'll tell you a simple trick through which you can find out the other quantities in terms of this base quantities, distance or displacement. Okay, but using that trick, it requires a bit of analysis. So let us move ahead, guys. And then we will return back to this questions. Right, guys. So here you can observe I have brought another two quantities, speed and velocity. So guys, let me just tell you the trick. If I have to find out whether any quantity is a scalar or is it a vector, what we will do is we will just think over the expression which is the very basic one. Like if I want to find out the speed, and how can I relate speed? As distance by time. There could be other formulas of speed as well, but we will try to think out the most basic formula. Right. So here always remember guys, distance, what was it? It was scalar. Displacement, what was it guys? It was vectors. And time, it is always scalar because time do not have any direction guys. So only these three things you need to remember. And let me tell you the trick. So if we have any vector, multiply that with scalar, you will get a vector quantity. On the other hand, if you have any vector and you divide that vector with a scalar, you will get a vector quantity again, guys, right? So let us return back. Let us use this analysis to finding whether speed is scalar or is it a vector. So here, guys, if we observe speed, it is distance over time. And if we look upon what is distance, it is a scalar quantity. What is time? It is a scalar quantity. So we look upon the table, there is no such information which match this scalar by scalar. So instead, it should be scalar. Only these are the conditions by which you will get a vector. If we talk about velocity on the other hand, how is velocity defined, guys? Just we will add instead of distance as displacement over time. So displacement, if we take here, guys, it is a vector, time is a scalar, and vector by scalar, guys, we have to look here, it is a vector. So guys, velocity is a vector quantity, right? So I think now it makes sense and you all can relate any expressions and you can find out whether that quantity is a scalar or is it a vector. All right. So moving ahead, guys. Now let us describe another parameter which is very important to actually explore full contents of this motion. So we have here acceleration, guys. Let us first define what is acceleration. Here, acceleration, guys, it's defined as the change in velocity with respect to time. This is the definition, guys. You have to remember the definition for acceleration. Later on, at the end, I'll give you the summary map that will just contain all the formulas which you need to just mug up in order to proceed ahead with any kind of numericals which we will do in our upcoming sessions, guys. So stay tuned, guys. Be focused and always be focused at the end when we will be exploring summary. All right. So guys, Acceleration, we have defined it as the change in velocity by time. So guys, if we talk about velocity, make a small note that there may be two kinds of velocity. One is initial velocity, other one is final velocity. So what do we mean by this initial and final velocity basically? Initial velocity, as the name suggests, it is that velocity which is associated at the start of the motion, and it's represented by the letter u. Final velocity, which is represented at the end of the motion, and we represent it by v. So guys, what will be the change in velocity if any object starts its motion? It will definitely be final minus initial. So change in velocity is going to be v minus u, and the change in time will be t. So guys, we can now relate the formula for acceleration, that is v minus u over t, right? This is acceleration. So guys, now if I would ask, what is this acceleration? Is it a scalar or a vector? How we can identify that? Definitely guys, it is a vector, and let us use our own methodology to just get whether this acceleration is a scalar or a vector. So guys, if you look at the numerator here, it's containing the change in velocity, and that change in velocity, it is a vector, right? Because if you subtract two vector quantities, you're going to get vector. If you're going to add two vector quantities, you're still going to get vector. Same thing, same rule applies with the scalars, right? So time is a scalar. So we get vector by scalar. And what we have learned, vector by scalar gives us vector quantity. So acceleration, guys, it's a vector quantity. That means it has direction associated with the magnitude, right? So always remember, guys, whatever we have discussed, the very much important thing in the physics. Because guys, if the bases are clear, you will find it very much easier to proceed ahead with other concepts. All right. So here guys, as discussed, we will be exploring the questions in the next lecture, because I do not want to make the video duration too much longer, because that would just, negatively, it will make you feel bored. So I'm just trying to keep the video short, basically 15 to 20 minutes, so that I can cover up concepts in some videos, and then I can move ahead with the questions in the next video. All right. So guys, that was all about today's concept, and do meet up tomorrow in the next session on YouTube, because guys, we are going to explore the questions what we did from today's lecture, guys, which is very much important in physics, right? So guys, physics, it's nothing but how much you explore, how much you apply mathematics to the real world situations. Okay, so let us discuss what we have already had in today's session. So first guys, we discussed about the motion. And what was motion? It was just the movement of any object with respect to surroundings, right? Next, we discussed about the types of motion, and we observed that the motion is of two types. One is uniform motion, another one is non-uniform motion. So guys, in uniform motion, we observe that the object covers equal distance in equal intervals of time. So guys, this definition, you will find it in your textbooks. But guys, if we want to actually understand the meaning of what is uniform, what is non-uniform, always remember guys, this is a kind of motion, uniform motion. It's the kind of motion which involves constant acceleration, right? It involves constant acceleration. But guys, on the other hand, non-uniform motion, it involves variable acceleration, right? We also explored few parameters here. Basically, we discussed speed as distance by time, and on the other hand, we discussed velocity as displacement by time. We discussed acceleration as change in velocity with respect to time, that is v minus u by t. And we also explored all about scalars and vectors. So scalars were the one which has magnitude only, and the vector quantities were the one which had magnitude as well as directions, guys. So guys, that was all about today's session. Let's meet up in the next lecture tomorrow, where we will start doing with some questions based on whatever stuff we had in today's session. All right, guys, see you tomorrow. Bye bye.